dear students. Now we are going to look at the design of Mod-26 Asynchronous counter. We have seen so far synchronous counters, asynchronous counters using various flip-flops. In asynchronous counters, we have used T flip-flop to build the asynchronous counter. JK flip-flop we have used. D flip-flop we have used. What we have not used is SR flip-flop. In this example, I would like to use SR flip-flop. So as usual, in step 1 we try to find number of flip-flops required. So in step 1, if at all I look at, so what exactly this is, mod 26. The given n value is 26. 2 power n should be greater than or equals to capital N. 2 power n should be greater than or equals to 26. Let's say n is equals to 4. When n is equals to 4, it is 2 power 4 greater than or equals to 26. 16 greater than or equals to 26. Invalid. Let's say n is equals to 5. 2 power 5 greater than or equals to 26. 2 power 5 is 32, 32 greater than or equal to 26. So n is equals to 5. What is n? Number of flip-flops. What exactly it is? It is the number of flip-flops. So the number of flip-flops required is 5. Number of flip-flops. Okay. So once we know the number of flip-flops, what we need to do? The next is what variety of flip-flop that you want to use in step 2. So in step 2, what exactly I would like to say is, let's use SR flip-flop. How to convert SR into T? We have seen SR to T flip-flop conversion. Let me show that. What we try to do is, we will give S input, R input. So there is a common clock, of course. Is there a clock actually, not common clock. There is a clock which is there for one flip-flop, in which we will have the outputs Q and Q bar. So what exactly that input is, S is equals to, we got an expression in conversion process, TQ bar, R is equals to TQ. So what we try to do is, you will take one AND gate, you will take another AND gate. For both the AND gates, what is the common input is T. So one of the input, okay, is Q. So this you are going to get it from Q. And for this, for the AND gate, output is S. This AND gate output is R. The another input of this AND gate is coming from Q bar. So now this flip-flop is going to act as T flip-flop. I can take the clock out, right? So here is the clock, CLK, here is the T flip-flop. So inside it is SR flip-flop, but for outside world, how does it look like? We have T input, we have CLK. So it is a T flip-flop. So what exactly that means is, SR flip-flop is converted to T flip-flop. For any counter, what is required is flipping, that is changing. So the changing of state of the memory is required. That's the reason why for every clock pulse it has to change its state. So that is possible with only T flip-flops. So either we can use T flip-flops or we can use any other flip-flop, maybe SR, maybe JK, maybe D. But only thing is, you need to convert that into T flip-flop and you can use it. So that process we have seen, how to convert SR into T. Now once this we have already studied, just we have recollected now. Now let's access transition diagram. So I need not like state diagram, I can say. So state diagram is very simple. Let me start at 0, then how many bits? 5 bits. Okay, then it will go to 1, 2, 3 up to how many? 25. So 0 to 25. So this will become a circle here, circle here, circle here. This is 0, 0, 0, 0, 1. Likewise, it will going from one state to the other state, and it will go, okay, or it will continue to here. What is the last state? The last state is 25. Here last state is 25, right? So this is state diagram. Or to make this very simple, It will go from 0, 0 to 1, 1 to 2, 2 to 3, 3 to 4, dash 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 up to 25, then it will go to 0. This in decimal we are representing, this is in binary, that's all. Okay. So this is state diagram. State diagram is done. Okay. So next what exactly we need to do? We need to look at truth table, of course. Truth table is input clock, output that we have. So what I can do is I can go for a simple technique where at what state I would like to make it to reset. That I can do to it. So what is the number is 26, right? There are two approaches. What is the two approaches is for 26, 27, 28, 29, 30, 31. For all these things I can make them equal to 0. Whenever it come across these states, okay, you can make them. Or I can make only for 26. Whenever it come across 26, I can make it equal to 0. So now I am approaching this. In the last lecture where we have seen, okay, mod 11 count. So in mod 11 counter, anything greater than 11 or 11 is used to reset it to 0. Now in this case, in mod 26 counter, I am not taking care of all the states other than, okay, 0 to 25. Only I am taking care of, if it come across 26, I will make it to reset to 0. So that it will start from 0, 1 to 3. So what is 26? Binary value. So binary value is 2 power 0, bytes of 2 power 1, 2 power 2, 2 power 3, 2 power 4. If 2 power 4 is 16, so 16 plus 10. So what is 10? 1 0 1 0. So this is what exactly. So let me call this as QA, QB, okay, QC and QD. QC, right? This is QC, this is QD, this is QE. So now what exactly the thing? QB, QD, QE, QB, QD, QE are ones. So what we try to do is we will take 5 SR flip-flops as we have shown, which we have configured into T. Okay, 5 flip-flops we will take SR flip-flops, which are configured as T flip-flops. How to configure them we have seen already. So such things we are taking 5. For all of the clears are connected tied together. Okay. Now this is being connected to a NAND gate. Okay, for which the inputs are, what are the inputs? QB, QD, QE. Whenever QB, QD and QE are ones, then it will get clear. Otherwise, it is going from 0 to 25. So all presets are there. They are connected to 1. We are not going to load any values of ones. Okay, we will starting from. So this is connected to 1. Okay. So what next? So there is a clock, active low clock. Output of this is input to the next. Output of this is input to, output of this is input clock to the next flip flop. Output of this is input clock to the next. Output of this is input clock to the next. So this is S input, R input, S input, R input, Q, Q bar, Q, Q bar, S input, R input, Q, Q bar, S input, R input, Q, Q bar. Similarly, S input, R input, Q, Q bar. Okay. So for everything, what exactly you will do? You take AND gate. One is input is T, another input is Q bar, T cube. What exactly? R is TQ, S is TQ bar. So S is TQ bar. So take AND gate. One of the input is T, another input is Q bar, other input is T. Similarly, I need to do it for this yes, this R, this yes, this R. Okay. For everything, I need to put one AND gate. For everything, I need to put one AND gate. Here, one AND gate. Here one AND gate. Two inputs. What are they? Q bar T, T, Q, T, Q, then Q bar T. Similarly, put one AND gate, give it to this. 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 Another input is T, another input is another input is Q bar, another input is T. Similarly, T, Q bar, T, Q, Q bar, another input is T. So likewise, if you do this, then what exactly is going to happen? It is going to function as, okay, mod 26 counter using SR flip-flops. So far, we have seen how exactly to build various flip-flops, various counters, okay, using different flip-flops like SR, JK, D, and T. Of course, we can draw the timing diagram. You can take the clock pulse and you can take the timing. When the input becomes, when the value becomes 1, 1, 0, 1, 0, it will become 0. So it will go up to 0 to 20. Okay, this is what exactly mod 26